Hi everyone, welcome and thank you for attending our webinar today, MDPI International Day of Clean Air Webinar 2023. And I am your facilitator for today, Yu Wu, and you can just call me Yo-Yo. And I am so delighted to be here with you today as we explore some important topics related to clean air. And before we dive into our agenda, I'd like to briefly introduce about MDPI. MDPI is a pioneer in scholarly open access publishing, and it has supported academic communities since 1996. Based in Basel, Switzerland, MDPI has the mission to foster open scientific exchange in all forms and across all disciplines. Our 428 diverse and open access journals, including 419 peer-reviewed journals and 9 conference journals, are supported by more than 115,000 academic experts who share our mission, values, and commitment to providing high-quality service for our authors. And now I'd like to take this opportunity to extend our warm welcome to all the experts and scholars who join us today. On behalf of MDPI, we would like to invite all experts recognized in their fields to attend the MDPI International Day of Clean Air Webinar 2023. The aim of this webinar is to encourage scientists to come together, take action, and raise awareness as to how the exchange of findings facilitates efforts to raise awareness of air pollution. Given the transboundary nature of air pollution, all stakeholders have a responsibility to promote the Earth's atmosphere and ensure healthy air for all. Working together across borders and boundaries, between sectors and beyond silos, will help reduce air pollution, leverage finance and investments towards air quality measures and solutions, and provide many benefits. And this webinar aims to encourage collections and collaborations among air pollution researchers and the international open access journals to share and discuss their research findings. And we are very much looking forward to seeing you at today's webinar. And before I get started our webinar, I'd like to go over a few items so that you can know how to participate in today's event. First, I have requested your permission to record our session on video file. The purpose of this recording is to help MDPI serve you better in the future, and no recording will be done without your prior knowledge and consent. And second, you will also have the opportunity to submit text questions to today's presenters by typing your questions into the question pane of the control panel. And you may send in your questions at any time during the presentation. We will collect these questions and address them during the Q&A session at the end of today's webinar. And now let's move on to our agenda. I'd like to take a brief look of our agenda today. First is the introduction of our webinar. And second, Prof. Dr. Peter Brimblecombe will give a speech on air pollution from fireworks. And third is Professor Dr. Ines Cavaros will give a speech on clean air, lesson learned, and future challenges. And fourth is the Dr. Marina Frontasava will give us a speech on atmospheric deposition of trace elements and radionuclides in Europe, Asia, and the Pacific region based on most analyses. And last part is the Q&A session. So let's get started to the first agenda. Prof. Dr. Peter Brimblecombe will give a speech on air pollution from fireworks. And I will stop share my screen now. And Prof. Dr. Peter Brimblecombe, you can share your screen now.
Right. It's really good to be able to talk to you all. I'm sure all around the world it's different times. For me here, I'm in Honolulu, Hawaii. It's just 6 o'clock in the morning. So it's good morning from here, but I'm sure it's good evening, good day, good afternoon in many parts of the world. So my idea was to talk really about this very special form of air pollution, which forms from fireworks. And although there's been much interesting research done in this, it's still a topic that's deserves much research, as I think I will argue. And I hope you may even, if you're interested, get some ideas for what might be valuable future research topics. So let me just see if I can move the screen on. Yes. Okay. So the outline of my presentation is that I want to talk about the fact that this is a global issue at the very beginning. I want to think a little bit about these brief exposures and their relevance to health. If you imagine, most firework displays are quite brief, so the exposures are necessarily short. I want to think about other impacts of fireworks, for example, the risks of injury, because fireworks are, after all, explosives. I want to talk about impacts such as the impact on visibility, because the smoke from fireworks can change and decrease visibility. I want to think a little bit about ecosystem effects. I want to talk about an increasing problem with illegal fireworks. And right at the end, I want to talk a little about research gaps and where we might think about new projects. Now, from an air pollution perspective, it's particulate matter, it's sulfur dioxide, it's reactive oxygen species, and toxic metals that are particularly relevant as pollutants emitted from fireworks. The toxic metals are, of course, relevant more from the ecological point of view, while the particulate matter may be a consideration from a health perspective. So this really is a global problem, and it's almost everywhere in the world we can find fireworks. Of course, in China, there's the Spring Festival, the Chinese New Year celebrations. In Mexico, Christmas is celebrated with fireworks. In the United States, it celebrates the Independence Day, and for example, in India, Diwali is a festival of lights celebrated usually late in the year. And then there are other places, and one of my favorites is Malta, the small island in the Mediterranean, where they do have some very large celebrations of fireworks, but often each little village celebrates its Saint's Day with fireworks. So this is almost like continuous throughout the year, and not a celebration that occurs on one specific day. So we might want to consider a very different form of exposure to firework pollution in somewhere like Malta compared to those where they have gigantic and very large displays on a fixed day each year. And what's characteristic of these emissions are something I've already emphasized, that it's very short term. So here you see in the United Kingdom, what happens is England celebrates with fireworks the 5th of November to commemorate the attempts to blow up Parliament back in the 1600s using gunpowder. And this is celebrated, and you see that the particulate matter in London on the evening of the 5th of November exceeds all other pollutant concentrations for the rest of the year. This massive concentration of particulate matter that occurs early in the evening on the 5th of November. And these very short, sharp peaks in particulate matter are really characteristic of fireworks-derived pollution. So this is a classic example. The other important thing to consider with fireworks is that the celebrations have an enormous cultural symbolism. So here we have commemorating the attempt to blow up Parliament in the 1600s. But each of the celebrations, Independence Day, Spring Festival, Chinese New Year, each of these uses of fireworks has a cultural symbolism. So curbing these emissions can be a complex issue for policymakers because it's not only pollution, it is, after all, a celebration. And so that's always a consideration that we have to consider if we're trying to reduce the emissions from fireworks. So Let's look at Beijing, Chinese New Year 2015 in Beijing. And this is just the trace of the hourly pollution measurements in 2015 as Beijing celebrated Chinese New Year Spring Festival. And what I want you to notice particularly is down here you see an increase in the sulfur dioxide level. So it was very obvious that we can see an increase in the particulate matter, PM10, PM2.5, but this little increase in sulfur dioxide was not so obvious. But if we think of it, this is perfectly understandable because fireworks, gunpowder contains a lot of sulfur. So one of the things we see, not only an increase in particulate matter from the smoke, but also an increase in sulfur dioxide from the firework components itself. And we would also expect, it's not shown here, it's not a regularly monitored pollutant, we would expect some of the metals present in fireworks to show the same thing. However, in this particular diagram, what we see is later on, we see increases in other pollutants. For example, we see increases in carbon monoxide. Later on in that day, we see increases in nitrogen dioxide. These are not necessarily related to the fireworks. Fireworks primarily emit the particles or the sulfur or the heavy metals. And we could try some kind of plot I show here now as an inset. And what we see is that really, although particulate matter increases across the bottom axis of this diagram, the x-axis, carbon monoxide remains relatively constant. And the reason is that carbon monoxide is not primarily derived from fireworks. It and the nitrogen dioxide would be derived from other processes within a city, and they would not necessarily show this sharp peak that we find with particulate matter or the sulfur dioxide or the heavy metals. So what about health impacts? Now, we've got to remember that these are short. We've seen these peaks in particulate matter are very sharp, an hour or so. This is typical of a fireworks display. So some small scale studies, and these are really being small scale, typically they only include a handful of individuals, often less than 10 individuals, but they do reveal that among sensitive individuals, asthma frequency is exacerbated. More people go to hospital. There is some decrease among sensitive individuals in terms of their lung function. So small-scale studies, you can certainly see the effects of these large and short peaks in particulate matter. However, in contrast, larger epidemiological studies, and a particularly notable one is a study by Grieven in the Netherlands, showed really no association between particulate matter derived from fireworks and daily mortality. And this Dutch study shows a very substantial increase in particulate matter. The particulate matter increased about five-fold over the normal level. So you would have thought that this short-term increase would be apparent in the epidemiological study. So it's not. And this hints that the effects of fireworks on epidemiology are rather difficult to find. They're complex and subtle, but short-term effects on people with respiratory problems have been detected. Or because of the small scale, I think there's still much to be done on these examinations of, say, asthma increase. Right, so where might the big exposures be found? Well, sporting events are increasingly celebrated with fireworks. And so some of the people taking place, the players, the sort of umpires, the field attendants in sporting events may be regularly exposed to firework pollution. And you see this kind of typical celebration here in a sporting match, I guess, from the field at soccer. The other people frequently exposed are those who work on the display. So you see here some on the right, some firework technicians, pyrotechnicians, working and developing a firework display, and they are also regularly exposed through occupational exposures to the firework emissions. So there are some people, some individuals will be exposed frequently to these high concentrations. So we may have to think about those occupational exposures. They have not been well studied, so they certainly form an area for further research. So the trends are interesting in terms of what's happening. So one of the things that happens with fireworks are, of course, that you get an increase in urban fire. So fireworks and the use of fireworks means that often there are house fires, domestic fires, and so on in urban areas. And the graph on the upper right shows that this is fortunately declining. The number of urban fires resulting from fireworks has declined over the last few decades. So that's really good news. Down in the lower left hand, you see the US consumption of fireworks, which has, over the decades gradually increased, and much of this usage is domestic. The amount of professional use in displays is quite small. So these changes suggest that fireworks as a problem are not yet going away in countries like the United States. And finally, this it's a little bit of a messy graph, but it shows this is the number of accidents that occur in the United Kingdom. And this is, I'm afraid, old data, 2001, but it shows how most of the accidents occur around the time of celebration. You have few fireworks accidents mostly through the year, but you have this strong seasonal increase in fireworks accidents, very much associated with the celebrations of Guy Fawkes Night in November. And so this shows that we have to consider a balance between fireworks causing problems such as asthma and fireworks causing direct injury. And often it's the direct injury that's much more apparent. Here we see in the United Kingdom sort of 300 events on some individual days. So strong seasonal distribution to this. And this seasonal distribution is driven by one of the legal controls in most countries. The purchase of fireworks has a very strong seasonal component. It's usually a short period prior to the actual celebration. So you see here, purchase in the United Kingdom stretches across 15th to 10th. The New Year fireworks are a short period, just in December. In India, in celebration of Diwali, 3 days before Diwali, you can purchase fireworks, and 3 days before Chinese New Year. So strong seasonal effect controlled by the legal aspects of the purchase of fireworks. So visibility. Very tragic accident in 2011 where fireworks contributed to a dense fog. The fireworks were being launched and used very close to a motorway in the southwest of England. There was a huge crash on the motorway, left 7 people dead, 51 injured, and this was partly blamed on fireworks, although in the end, legally, they decided that the contractor who launched the fireworks was had no case to answer. But it shows that fireworks can be implicated in reduced visibility. I also mentioned this idea of environmental effects. And for example, in Hong Kong, fireworks are frequently used at Disneyland, Disney World, to celebrate the evening, and these led to deposition of heavy metals in the harbor, although it proved in the end it was only a minor effect. However, in some places, fishermen do report that the toxic impact of metal from fireworks in terms of fishing, there is perchlorate from fireworks found in lakes. For most people, environmental exposure of this kind is relatively low. We tend not to be affected by the changing metal concentrations or the chlorides in lakes. And the other question is for ecological systems, the enhanced reactive oxygen species. But this data in the UK shows the emissions of copper from fireworks has gradually declined. Partially, this is an interest in the use of less metals within the production of fireworks. So, to return back to this idea of just air pollution in cities, one might say, well, oh golly, well, this is just a problem of big cities. So, the bigger the city, the more fireworks that gets used. Therefore, what happens is it's a big city problem. But this is not quite true. And what you can see here is that very large cities of China, Beijing, Chongqing, and Shanghai has very little fireworks pollution. And Beijing in 2015 had a lot of fireworks pollution. So this 2015 data shows that individual cities are really quite different, even though they might all have very large populations. But you do see that some of the smaller cities have the lower population cities have lower particulate matter from fireworks. However, laying the cities out here, and this is the 2015 Chinese New Year, and just showing the evening and the morning of Chinese New Year, what you see is different characteristics. So you see the northern parts of China show these very strong peaks to particulate matter just after midnight as they celebrate the new year. Whereas some other cities, Chengdu, Shanghai, Shenzhen, more in the south, in the middle of China, these don't show these strong fireworks peaks. And finally, you have places like Hong Kong, Taipei, Kaohsiung. These cities have very little celebration, very little private use of fireworks. Some of them occasionally have public festivals, very little private use of fireworks. So we don't see any peak at Chinese New Year at all. So this suggests some level of control. One of the problems from fireworks that we haven't considered, an environmental problem nevertheless, but is the waste material from fireworks. Here you see a Chinese city where it almost looks like red snow. This is the red paper that covers the classic Chinese firecracker. And the streets can be littered with this kind of red snow. And you see here some on the road, you see this young boy clearing away the firework debris. In fact, for some cities, this was so serious that it meant that people opted to control fireworks, not so much because they were worried about air pollution, but they were worried about the firework debris that covered the streets. And this was true for the city of Nanjing. So Nanjing was really worried around 2010, and its government was seriously concerned about the impact that this waste red paper and this firework debris had on the city. It was costly to clean and so on. And so if you look at what happened in Nanjing, you can see the mass of fireworks used declined substantially. And this meant the debris declined. So 2010, it was 80 tons. 2011, it declined to 195. And then 2012, 170. So slight decline. And then for the whole 2-week celebration, it was 2,000 in 2013. So they tried very hard to reduce the amount of firework use and hence the debris from the fireworks. This success is revealed in the concentration of particulate matter in Nanjing. So what you see is 2013, you see a very high firework peak. It looks much like Beijing. Then you see 2014, they adopted stricter controls. And then by 2015, Nanjing had a ban. And you see this firework peak vanishes completely. So Nanjing was really successful in changing the profile of the particulate matter from fireworks over this 3-year period of increased regulation. So in a way, it's a kind of great success story for this Chinese city. Let's look now a little at Beijing, and we look at the sort of profile in Beijing. Beijing, and often I feel sort of northern China, has been much more enthusiastic about the celebration of the Spring Festival with fireworks. And I just show here, I don't worry so much about the actual change. You can see increases from 2014 to 2017, and then a decrease. But I just want you to look at the increasing concentrations of particulate matter found not in the center of the city, but in the outside of the city beyond the Fifth Ring Road. If you know Beijing at all, you know there's all these sets of ring roads around Beijing. And what you can see is that this has largely become, this fireworks pollution has largely become a rural problem that occurs beyond the Fifth Ring Road. And there's a number of reasons for this, and you see it in many cities. Regulatory controls are often tighter in the center of the city. So it's possible to regulate fireworks in the center of the city. It becomes more difficult to regulate fire on the periphery of a city. So this is, and sometimes the regulations, as they are in Beijing, prevent the use of fireworks or restrict the use of fireworks within the Fifth Ring Road, and they're more liberal outside the Fifth Ring Road. So this notion of an inner core that tends to be better regulated and an outer than a periphery of the city is really very common. It's not only true of Beijing, it's certainly found elsewhere. And this arises for a whole range of reasons. So in Beijing, fireworks gradually became very difficult to buy within the center of the city. And what you saw was an expansion of these pop-up stores where fireworks were sold at the margins of the city. And not only sold, therefore they became often used. There was also a problem that many of these fireworks being sold were actually illegal. So what did Beijing do? How did its policies evolve? Because Beijing has been able to curb the use of fireworks over the past decade. And so we see here the sales of fireworks over time, and what we see as the actual sales have been gradually declining. So a declining number of quantity of fireworks being sold. But of course, part of this is a movement out of the well-controlled center of Beijing to the periphery. Very difficult to get hold of the number of illegal fireworks being sold. But what we can see is, as far as we can track the records, illegal fireworks were quite frequent up until about 2017. And then it's very hard to trace. So this may represent policy, a control on illegal fireworks. So the pressure is certainly when the Beijing government used the internet to try and encourage good behavior. It, for the early years, was very active in promoting control. And then in later years, it tried to curb illegal activities, reminding citizens of Beijing not to purchase illegal fireworks. And this increasing pressure has certainly been successful. One might want to contrast this with India, where illegal fireworks, at least until very recently, have been a problem. India has had much more problem in controlling fireworks in its city than Beijing. It may well be that the different forms of the way government regulations are enforced, a more central control of emissions in Beijing, and a more laissez-faire approach in India, where it's been more difficult. But you can see some success, at least hinted by the way in which the official internet was used. But also, what is nice to see is that public support for fireworks has been eroded. And there were many people who were just really horrified with the notion this attack on the cultural importance, the Nian culture of China, this idea of loud noises at New Year to frighten away demons and so on. So this is a very important culture. And I love some of the little notes in the internet, and I love this little quotation about this saying that his father loved to buy fireworks, but finally in about 2018, the father said, well, I'm not buying any more. There's such poor air quality that I want the festival, the Spring Festival, to be greener. And it was a really nice little thing. And you see here again, looking at the online data, the frequency of support for fireworks declines in Beijing over the years. Then you might say, well, this is just typical of Beijing. This problem with illegal fireworks, this problem with attitudes. So I look here where I live now, Honolulu in Hawaii, and this is tracing in Honolulu, you require a permit. You have to purchase a permit in order to use fireworks to celebrate New Year. And this is calendar New Year. So what we find is that the number of permits has been stable over time. I mean, the number of permits may have increased slightly, but it seems to be now vaguely in decline. And you see the number of permits issued in 2020, the 2023 celebrations. These were emitted just before the celebrations of 2023. But you see, 2023 was very notable for very high levels of particulate pollution in Honolulu. So the permits don't agree with the particulate load. In fact, the permits almost seem inverse to the particulate load found in Honolulu. So we have very bad pollutions here. And the injuries also follow this, although we don't have the injuries for the most recent years. So the belief among experts and government in Honolulu is that actually firework use has increased. Even though the permits are relatively stable, fireworks have increased. And what you see here is that there's no increase in permits. Therefore, the assumption is that it's illegal fireworks. Fireworks are being brought, large quantities are being brought in illegally, and this is a major problem for Hong Kong, for Honolulu. We have these large quantities of illegal fireworks, and it's these that are contributing to injury and the air pollution. So it's a very big problem, and because Honolulu's port is very, very large and very active, there are so many containers coming into the port, it's very difficult to inspect all these for illegal fireworks. So it's a problem that Hawaii faces that's really causing a lot of worry at a legislative level. So what do we do about this? Well, a number of countries have adopted different things. Taiwan has increasingly been interested in the notion of lanterns in celebrating the Spring Festival. So this is often LCDs and lanterns are used in the celebration. This used to be Hong Kong in the old days. Hong Kong used to frequently celebrate, almost every evening. It would celebrate over its beautiful Victoria Harbour. You'd have these wonderful displays, fireworks displays, but they decided this was not a good idea, not a good idea from an air pollution point of view, not a good idea from the perspective of heavy metals and the deposition in the harbour. And this is replaced by an equally magnificent festival. Every evening now you can go down to the harbour and you can watch this amazing laser display. The lights in the buildings come on and off. They are coloured. There's lots of neon, and then there's these wonderful, there's lasers, there's searchlights. It's a really stunning display, but not using fireworks. So that's been a really big transition for Hong Kong. So what are the research questions here? So it's clear that we have hints of the respiratory impact of fireworks, but we really don't have good observations of that. We don't see much epidemiological impact of this on respiratory health from these short fireworks events. We have some hints of increases in asthma emissions for hospital, for example, but these are not really very satisfactory because the numbers are so small. So what this suggests is that this would be a good area of research, that we need to know more about really the effects of these short exposures. to fires. Then studies of worker exposure, pyrotechnicians, the people who work at football matches, for example. This is not well studied. So there would be really good area of study, but to begin to measure concentrations of fireworks pollution at these sporting events. And as far as I know, I have not seen any measurements of particulate matter derived from fireworks at these large sporting events. We know from other things like the Beijing Olympics, for example, you could see changes in particulate levels during the Olympics in 2008, but not specifically any sport-related firework use. Then I think there's a very interesting case that in a number of countries, they don't have one massive festival. They don't have Spring Festival. They don't have Independence Day, July the 4th, but rather they have multiple little exposures, as they do in Malta, regular exposures to firework pollutants, small amounts in the villages, week by week, as they celebrate different saints in different villages. So very little research. Some research on Malta, but only a little. Then there's the question of exposure to privately used fireworks versus public displays. And one of the things is that public displays are often at altitude, so everybody can see them. So the emissions are 100 meters or so above the ground, whereas private use of fireworks often means the emissions are virtually at ground level. So I think that looking at the exposure that comes about through private use of firework and public display is also very relevant. And finally, this whole question of the importance of illegal fireworks. And here, I think it would be really interesting to try and see if it's possible, perhaps using metal traces, to try and distinguish between the pollution that arises through the use of legal fireworks in the city and illegal fireworks in the city. That would enable regulators to start to be able to assess the extent to which it's illegal fireworks that are causing the problem. Because the kind of techniques of tracking the quantities of illegal fireworks is very difficult. I mean, we've tried very hard to work out the quantities of illegal fireworks, and it's extremely difficult. So I hope those research ideas seem relevant to some of you and perhaps offer a possible future research topic, because it's a very active and interesting field. And finally, just to conclude, I would like to say that this is an important and complex issue because of its cultural relevance. I mean, environmental regulations often have to limit our freedom to drive cars, our freedom to have fires, coal fires in our houses. Environmental regulation tries to control our behavior. And unfortunately, this is another control. If we're going to control firework use, we control individual behavior. However, I think there are clearly ways where we can still celebrate the Spring Festival, the Chinese New Year, and it can still be enjoyed even though we may not be able to use fireworks freely in the way we did in the past. So I hope you found that interesting, and I'm going to end now because I know we have another talk that will immediately be followed. But I look forward to the questions in an hour's time.
Thank you, Professor Bringbong Kong. Thank you for sharing us with the detailed visualized data of the use of fireworks in different countries and the comparisons between the different geographic locations in China and its influence of the fireworks used and its potential concerns in the city. And we appreciate your sharing and the insightful knowledge. And now let's move on to our next agenda. Let me share my screen. Let's invite Professor Dr. Ines Cavaros to give us a speech on clean air, lesson learned, and future challenges.
Now everybody sees my presentation. I would like to thank you for the invitation to join this esteemed panel. Dr. Brible Koppe and Frondasheva, I've been reading your publications since my age is since I was a student, I'm very pleased to be part of this panel with you and learn about the interesting thing you do. It was funny about the fireworks in New York City. Now we open after COVID. This summer was pretty bad. There was on 4th of July there were fireworks everywhere. Even my teenage kids commented on not on the fireworks, but on the smoke, on the plume they create after. So, but with your permission, I would like to expand a little bit the scope and see what we learned the past 30, 40, 50, 60 years on working on air pollution. And although my study or this presentation uses information and data in the United States, that's where a big significant work has been done. Then these lessons can be applied everywhere as both the developed countries as more importantly the developing ones. So all of you know about the history of air pollution is not new. It dates back thousands of years, but the most recent was the events in Belgium, Pennsylvania, London, then Los Angeles, and the acid rain in Great Lakes that triggered action regarding air pollution. Putting things in the air was the easy way to go for most of the anthropocentric activities in the last couple of centuries. But then when we put too many of these pollutants in the air, they started coming back to us. And these events triggered action, triggered environmental losses, as Dr. Brible mentioned before, as an effort to control what we put into the air and how it affects our health, well-being, and quality of life. This slide here shows a brief summary of these environmental laws. Actually, these are all the environmental laws since the 1895 in the US. The key point here is the following the events with acid rain as well as the ozone pollution in West Coast is the establishment of the Clean Air Act in the United States back in 1963, as well as the amendments since then that expand the rules and the pollutants in which the Clean Air Act has a jurisdiction over. So the key components of these laws, as well as others to prevent pollution in the workplace, in water and soil, and other environmental media. But the key component of the Clean Air Act is establish primary and secondary standards for a subset of air pollutants identified as criteria pollutants. As you know, there are different terms around the world. In the United States, they're called criteria pollutants, and this is carbon monoxide, nitrogen dioxide, sulfur dioxide, ozone, particulate lead, and two fractions of particulate matter, PM10 and PM2.5. So the primary standards aim to control the levels of these pollutants in the air to protect human health. The secondary standards aim to control the levels of these pollutants in order to protect environmental ecosystems, with visibility being one metric of those. But as you know, the air doesn't contain just these 6 pollutants, contains thousands of others. And we'll talk a little bit about that. For the other pollutants, there is a set of rules and regulations that minimize or try to control their exposures. That is the MACT standards, the maximum achievable control technology. So, and based on these rules, particularly for the criteria pollutants in the US and around the world, there are areas that meet the standards and they are in good hands, although there is no safe threshold for air pollution. Even at very low concentrations, it can cause significant health impacts long-term to the general population as well, to susceptible population groups. But those who exceed these thresholds identified as non-attainment areas, and then they have to act on that to reduce emissions in order to reduce pollution. So, and that has been measuring air pollution because of these rules has been one of the outcomes has been the development of an extensive network of air pollution monitors in the US. The panel on the left here, on your left side, shows the network of PM 2.5 monitors in the US today, which is already a lot. It's about 2,500 locations in the US alone. As you can see, if we were to overlap the population, it will be where people live. There are areas, significant areas here that are missing. These are desert, agricultural fields, and so on. So it's concentrated in areas. But actually, it's not only that. Over the years, there were other sites that have been commissioned and decommissioned. So in this slide here on the bottom right shows the slides that have been active sometime during the past 40 years, actually, and measure the same pollutant. So if you put the two maps together at different points of time, there is a substantial number of data available, measuring air pollution, understanding where it's coming from, try to quantify or evaluate the impacts to health and quality of life. So over the years, and this information ran back 30, 40 years. So there is today there is a wealth of data that we can use it for different purposes. And one of those purposes to try to address whether all this pollution or regulations we put in place are actually working or not. And this slide here shows the air quality trends for the criteria pollutants in the United States over the 1980-2022 period. That includes also the COVID era. So, and as the primary control regulations aimed pollutants associated with acid rain, that is sulfur dioxide and nitrogen dioxide and carbon monoxide, you can see that their levels significantly dropped at the end of the 20th century. And in order to control these levels and the particles and acid rain associated with that. And then the same trend was more or less true for the other pollutants. Ozone, lead, of course, significantly reduced, but ozone and the two fractions of particulate matter, but not at the same rate, the same slope. As you can see, a very fast decrease, SO2, NO2, a decline, but not as strong for ozone, PM10, and somewhat more important for PM2.5. So today, where we're standing is most of the United States, although there are areas that exceed the thresholds for the three, sulfur dioxide, nitrogen oxides, and CO, but most of the United States actually has low concentration of these three kind of legacy pollutants, but there are significant concerns about achieving the standards for ozone and particulate matter, particularly as new knowledge indicates that actually, as I mentioned before, there are impacts at concentrations below the thresholds, below the standards established by the regulation. So, but one thing that we learned through the analysis of trends is that as the air pollution decreases, and that imposes significant changes, as the previous speaker mentioned, on the way we do business, the way we act, the way we live our lives, on the way the economy is running. Actually, since 1980s, as the pollution declined, or as all these factors improved, gross domestic products, vehicles miles traveled, that means more vehicles in the air, more vehicles on the streets and driving longer. The population, of course, energy consumption increased. Because of the regulation in place, air pollution declined. So an argument that better air quality or regulations actually impede economic growth in the long run, it's not true, because for multiple reasons. One is the economy adapts and new technologies are developed, and that means jobs different jobs, not the same jobs, but that you tend to be usually better and higher paying jobs. And then standards behave. So as we've seen, and individuals actually behave differently. As we've seen, the vehicles miles travel increased, which is more cars on the streets driving longer, but because of the quality of the fuel improved and technologies to reduce emissions, it's actually emissions reduced. So better air quality, it's actually, if it's done properly, and it can support economic growth. It's not either or, we can have both. The second lesson we learned over 40, 50, 60 years of research is, as mentioned before, is the thresholds. It's a compromise between what can be done and what is technologically can be done, and what is the knowledge of epidemiological studies showing effects of air pollution on human health. There are, as we mentioned, there are well-known effects at lower levels. So that means that although a lot of areas comply around the US, again, comply with the national ambient air quality standards around the US, there is still many areas that are violate the standards, either for 1, 2, 3, or all 6 criteria pollutants. And this map on the right shows where these areas are. And if you can notice, is around the southern or central and southern California. And then the second area is along the northeast corridors. Now, for those of you in the US, but more or less everybody knows that the most populated areas in the US is around the Los Angeles area and around New York City, the eastern corridor here. So actually the areas where most of the population is living, or significant fraction of the population is living, are areas where people are still exposed in unhealthy, according to the regulations, levels of air pollution. That adds up to 85 million in the United States, which is about between 1/3 and 1/4 of the population in the US for at least one NACS, and most of that is ozone. So ozone is one of these pollutants, as you already know, that we do not release it from something. It's not released from any activity, but it is the product of reactions in the atmosphere from pollutants, from nitrogen oxides and volatile organic compounds we put in the air. So in order to control ozone, then we need to control something else. That's nitrogen oxides and VOCs, and we need to understand the chemistry, how all these things work together in order to make meaningful reductions and controls. But as I mentioned before, there is the secondary standards that aim to protect the environmental ecosystems. And visibility, as the previous speaker mentioned, is a primary indicator for that. In the United States, the visibility is measured, is considered the indicator to evaluate improvement of air quality in national park, forest, monument, and wilderness area. All these are federally protected areas that in addition to restricting any anthropogenic activity, they are regularly monitored. The air pollution is monitored through the improved network. It's a total of 150 sites in the US, and the monitoring in these areas, although rural background areas, it dates back to 1980s. So over the years, and again, it's triggered by the significant reduction in the visibility in these national parks, which has implications on the well-being of individuals and the economy to some extent. You can imagine, people flying around the world to go to Grand Canyon and spend all this time and resources, and then you are there and you see something like the top half of this photograph here that you cannot see from the south part of Grand Canyon, the north part. and that is a disappointing experience. So because of these regulations and the controls that's been put in place to reduce air pollution, actually visibility in these national parks improved. And the two maps down here shows how the visibility was at the beginning of this century and what is the visibility now. And if we were to put a similar map back to 1990s, the differences will be more obvious. So now we have more frequently views of the Grand Canyon the way it is presented on the bottom part of this figure here on the top, where you actually can see the north rim from the south rim of Grand Canyon, which is if you've been there, it's a thrilling experience. So there is a improvement also on the visibility, and that, putting together with the previous lesson, it indicates that although regulations tend to change the way we do business, in the long run they produce measurable and maybe medium term, they produce measurable improved metrics, both for air quality and human health, as well as visibility and the sustainability of environmental ecosystems. Now, as we monitor air pollution, we see what is done, but since we cannot control how the atmosphere is behaving, the only way to control the air pollution is what we emit into the air pollution. So this is the only tool we have controlling emissions. So, and at some point there was an exercise trying to relate how much do we need to reduce emissions in order to see meaningful change on air quality. So the table on the left side shows the reductions on the ambient level of the criteria pollutants between four distinct periods, between 1980s 22, 1990s 22, 20 and 22, and 2010 and 2022. See, this is about, on the left side, the ambient air quality. On the right side are emissions. And as you can see, for the legacy pollutants, carbon monoxide, SO2, sulfur dioxide down on the bottom here, and NO2 in the middle, there is a relatively good alignment between emissions, the reductions in emissions, and the reductions in air pollution level. And that makes sense because most of these pollutants are, what we measure in the air is related very well with what is injected in the air by mostly anthropogenic activities. There is no large atmospheric processes that contribute to the ambient or affect the ambient levels of these pollutants. However, the picture changes quite a lot for particulate matter and ozone. For example, for ozone, there is no emissions. We have to go understand the emissions of volatile organic compounds and nitrogen dioxides. And although for nitrogen dioxide, emissions the last 30, 40 years were down 50, 70% or 50%. And for VOCs has been down up to 60% since the 80s. Actually, ozone concentrations declined by a mere 30% compared to the 1980s. So that gives us an indication that the relationship, as we know now, between ozone precursors and ozones is not linear. And it's highly variable over time, over space. And that impedes significantly our efforts to control ozone. The same is more or less true for particulate matter. Significant reductions in the emissions of the PM2.5, that's the smallest particles, and then PM10, that the smallest particle plus some of the larger naturally emitted particles. Again, these reductions in emissions do not actually reflect the reductions in concentration levels. Sometimes it's more, sometimes it's less. So that also provides an indication that there are other sources. There might be other sources that contribute to this. Keep in mind that when we calculate emissions, or back in the 80s when we started, the aim was to control what the anthropogenic activities put in the air. So a lot of emissions monitoring, emissions modeling was about controlling anthropogenic sources. But as we have a tight control of what anthropogenic activities put in the air, now other sources start to play a role on this. And these include biogenic sources. Some of them existed there, some of them developing over time. So this slide here is that we focus mostly on controlling the anthropogenic emissions, stationary sources or mobile sources, traffic, and then industry. So, and over time, although we don't show it here, we've done a pretty good job on controlling those. But environment is evolving, atmospheric is evolving, and climate is evolving. So one thing we never considered seriously is that the environmental ecosystems, the trees, the plants, by themselves emit volatile organic compounds, which is by themselves are not carcinogenic or toxic to the humans, but are organic compounds that react, and the reactions lead to formation of ozone. So now we're back to start considering the last 20 years, 30 years, considering the interplay between VOCs, both those emitted from anthropogenic sources and natural sources on ozone. And then, of course, the elephant in the room for many areas around the world, including in the US, including here in New York City this summer, is wildfires. That is an event directly related to climate, and that contributes significant amounts of many pollutants that affect the air quality nearby the fire, but also further away at different ways. As pollution, smoke evolves over time, some of the particles may settle down, some new particles may be formed, and ozone may be formed. So there is this evolving situation with fire sources. And of course, as many of us experienced the last few years, the intensity and the number, intensity, and magnitude of these fires is increasing rapidly. So, but as I mentioned before, all this discussion was about the criteria air pollutants, and this is not the only thing we breathe. The air contains thousands of other chemicals. A large group of those are known as air toxics, and it includes heavy metals, as it mentioned before. It includes volatile organic compounds. Many of those are also involved in the formation of ozone, and includes polyaldehydes like formaldehyde and acetaldehyde, which is either emitted primarily from an anthropogenic source, but also can be formed in the atmosphere, and it includes polyaromatic, polycyclic aromatic hydrocarbons, both in the aerosol phase and in the gas phase. So it includes, I think it's a total of 150, 160 compounds that are in the air at very, very low concentrations. But long-term exposure to those can cause significant health outcomes to individuals, both cancer. Many of those are recognized as or suspected to be carcinogens to humans, and other non-cancer effects, neurological or in the respiratory tract. So there is no regulations on the levels of those, but there are regulations on the emissions of those. But there is some monitoring along the United States and many places around the world. These three maps here shows the top right, the measurements of the levels of these air toxics are around the United States, with a dark red means the higher the concentrations, the higher concentrations. So, and as you can see, if you if you understand a little bit where the major urban areas in the United States fall in, you can see the red hotspots are where major major urban areas are. And in many cases where there is significant industrial activity, the affected area is significantly larger. A good example is the Houston area that has, other than being the metropolitan area, a large metropolitan area, it's the largest port and it's a large port along with New Orleans and this region, and also a significant number density of oil refineries and oil processing, not to mention, of course, all the oil and natural gas exploration platforms off the coast there. And you can go to Los Angeles, you can go to Utah, Salt Lake City, and other urban areas, particularly in the Midwest, where many coal power fire plants are located. The two maps so this tells you the ambient levels, and these two plots here on the bottom side of your screen shows the carcinogenic risk on the left side and the non-carcinogenic risk on the right side, based on the air toxic concentrations. So you can see it doesn't, not some of the urban areas, particularly in the southeast, are also highlighted here, but it doesn't highlight all the urban areas because it's not only what it is in the air, but where people live or how people live and their exposure patterns on those, and also socioeconomic factors. So traditionally, the Southeast United States has been an area of significant disparities and disadvantages among minorities. And although the concentrations are not very high, there are actually a lot of people exposed at lower concentrations. So cumulatively, over a period of time, the risk to develop cancer or other non-cancer health outcomes because of lower exposures to air toxics is increased as compared to, let's say, those living in Salt Lake City or in Arizona down here. So in other words, yeah, the concentrations are there, but what it matters is exposure. It is dose, and over long term, the time is a critical component. Long time over low concentration is very it can be a significant determinant of health outcomes. So, and of course, air toxic, as I mentioned before, wildfires and other non-anthropogenic activities are becoming an important concern, and many of those wildfires, is linked directly to climate change. And this map here shows what I mentioned before, that air pollution, it is a local concern. You know, as I mentioned, if areas do not comply with the national ambient air quality, they have to put in place tools, strategies, policies to control emissions in their jurisdiction. But with the wildfires being an event that affects many communities further away from the fires, you can understand controlling the air pollution in areas, it might be an extremely difficult task, particularly if smoke, for example, is a significant component of air pollution coming from areas further away. Let's say, for example, in New Mexico and Arizona, impacted by wildfires, in Idaho, or northwest United States, or even further north in Canada and Alaska. So understanding, and we've seen there is a trend, consistent trend, that the number of fires is increasing in many places around the United States, Western United States. And if some of you are in Eastern United States, we've seen that being the case now, with fires coming closer and closer along the Eastern Corridor and closer to urban areas here. So that is an important component. The other component that has global implications and also important in the United States is drought. And that because it controls emissions of dust, large particles. Now, dust, it's soil particles, is not carcinogenic or toxic to humans. It's natural material per se, but it is, when there is the surface is quite erodible and wind blows over them, it can create these massive plumes, and these plumes, this surface erodibility increases with drought, which is a significant it's a climate related outcome. And I hope this sequence now here is going to show how the drought changed in the United States over the 2022 period. As you can see, the areas west of the Mississippi River is highlighted, but if we have time and we're run it over the late summer of 2022, let's see if it goes fast. It goes really fast. Now you start highlighting areas that were not traditionally under drought in the past, and that has potential implications, not so much for wind-blown dust, as it is the case due to the desert areas down in the southwest, but it increases the risk for wildfires. So drought can be a source of wind-blown dust in one area, can be a risk factor for wildfires in another area. For example, northwest, where are dense forest, and drought, it basically prepares the biomass, dries the biomass, and makes it susceptible for wildfires. Now, what we learned here is that we've done as humans quite a lot of work on reducing the air pollution in the United States, but around the world, mostly in the developed countries. And but we need to change. We need to consider more variables here. So, and we know the things we don't know. And for those going back 20, 30 years, this phrase came out of the infamous defense secretary in the United States regarding the Iraq war. So the things we know but we don't know how they are going to affect air pollution are wildfires, drought, the atmospheric chemistry, and how anthropogenic emissions will change over time. And if we continue to improve air quality, we'll need to include those. And of course, there are things we don't know that we don't know, and how they will affect the air quality and the air, and that is abrupt climate and weather changes, and how those will affect the ecosystem. Multi-sectorial cascade impacts. Atmosphere is not alone. It reacts with the other ecosystems. It reacts with the human ecosystems, and if something triggers a response to one, atmosphere will most definitely impact it. Technological advances that may improve air quality in ways we don't understand, and of course, economy and society. But the world is not only made of the developed countries, the world is mostly low-income and developing countries. And there is a great opportunity for us moving together, for the developing countries to use all these lessons learned through developed countries the past 30, 40 years, and grow in a sustainable and environment or atmosphere friendly way. But considering the lessons learned, we don't need to go through the growth of their economies and repeating the same steps of the 19th and 20th century air pollution, but think how to grow their economy and their countries, but in the eyes of 21st century pollution controls and policies, and integrate technologies and tools we learned. For example, the coal-fired power plants. There is a excellent technologies in the United States that reduce emissions by a lot. They can be used abroad and in other countries. So with that being said, there's a lot of things been done the last 40 years on air pollution. We're in a much better place than we used to be, but there is still work to be done. in different fields that can bring together and continue to improve the quality of the air we breathe. Thank you.
Thank you, Professor Cavaros. Thank you for your insightful speech. Thank you for sharing us the environmental notes and the monitoring practices being used in the United States. And we appreciate you talking us through in details about the lessons we can learn from the previous experience. Even though there are some challenges still in front of us, we can definitely expect a bright future in and less air pollution in the coming years. Thank you. And now let's move on to our next agenda. Our Professor Marina Frontasiva will give us a speech on atmospheric deposition of trace elements and radionuclides in Europe, Asia, and the Pacific region. Assessment based on MOS analysis. Let's welcome her.
First of all, greetings to everybody. I noticed that around 50 persons participate. And if, for example, some of you will approach me after my presentation saying they would like to join the United Nations program on air pollution, that will be the main target and my great decision of my presentation. So please, can you help me with
Yeah, sure. Just
So I
one
represent International Organization, Joint Institute for Nuclear Research. And in my presentation, I shall demonstrate the possibilities of nuclear and related analytical techniques using for air pollution studies. Usually addressing to the audience, I say, without food, a person can live 1 month, without water, 1 week, and without air, 5 minutes. That's the importance of studying air pollution in general, like our previous speakers told in their specific things, and from particulate matters and say gases pollutants. I switch in my presentation, as you may see in the title, trace elements and radionuclides in Europe, Asia, and the Pacific region, assessment based on MOS analysis. For some of you, probably this word MOS sounds in a strange way, but you will know about that extremely nice technique, which is widely used for more than 50 years already. So I switch to the next. So please, so you will conduct changing slides. Okay, so I shall speak about international cooperative program of the monitoring and evaluation of effects of air pollutants on vegetation. So the program is called ICP Vegetation. It is established under the Convention on Long-Range Transboundary Air Pollutants by Economic Commission for Europe, not environment, but economic, because as you may understand, air pollution involves a great economic aspect of this assessment. So convention is the greatest legislation above only God, as I say. So many countries, next please, many countries signed agreement, Convention on Long-Range Transport. It is dated by 2007. That picture is taken from the United States, United Nations website. It doesn't know new, but those countries in green, they signed that convention, but not all of them contribute really with their results to this program. So if someone of you, dear colleagues who are listening to my presentation now, will approach me later with the desire to join that program, that will be great. Next, please. So, can you change the slide, please? This picture, just to ensure you that we deal with the team. No, the previous one. You deal with the team, which deserve, say, trust. All in all, we have published 556 publications at the moment. Okay, you see my name here, but it's really great work of the department, which was conducted by me for more than 20 years. Now I'm director advisor, but you see, those who understand Hirsch index is quite high, and I'm very proud to say that we are the team whom you can trust in their analytical research for air pollution studies. Next, please. No. So I must say that our department, our sector of neutron activation analysis played great role in coordination of the European MOS surveys, because in 2014, due to the interests of the United Nations to move to the east, to involve parts of the world like Caucasus, for example, they were interested to move that program to the east. And so Joint Institute, because our dedicated contribution to that program, please return, please, return. It's too early. Yeah, return. What's happened? Just before yeah. So in 2014, Joint Institute has become coordinator of that program. But due to the known events, which are at present political things, in February 2023, after roughly speaking 10 years of coordination, returned to United Kingdom. Next, please. Next, please. So briefly, to show you the importance of that program, it's not a program for one day. It exists starting, say, from last century, 1986. MOS technique was first proposed, and you see the names of these great guys from Sweden. And so it was Scandinavian countries, UK, coordinator Erik Steinitz in Norway, Sweden, and then it moved to Denmark, Finland, Norway, Sweden. So countries where mosses are growing well in their humid area. And then later, some more countries, also say North European countries, Estonia, Latvia, Lithuania, joined this program. Then it moved to Central European part, and starting from 2015, 36 countries participated in that program, and coordination was going on from the Joint Institute in Russia. These are COVID years, which results are not yet discussed. In 2020, usually 2 years are given for MOS survey collection of mosses, but it was prolonged for 2022 due to COVID-19, as you may understand. Next slide, please. So these are the picture which should ensure you in the interest of the growing interest of the countries. Here you see the number of participants, and here number of the countries. All in all, now it's up to 49, to be precise, in the last MOS survey, 39 countries participated. And these errors show the meetings which were held in the Joint Institute for Nuclear Research. Next, please. It was 2007 and 2016, such big group of participants, and I really think that some of you maybe will join us, a group of the participants where you can see representatives of the United Nations, Professor Staines, Harry Harmans, great people from UK, and so many participants from all of the Europe gathered together. It was 29th task force meeting held in the Joint Institute for Nuclear Research. Next, please. So the annual meetings helps us to exchange opinions and to proceed with the results. Joint Institute is an international intergovernmental organization. That is full list of the countries which existed before 2022. Next slide, please. As you may understand, due to political events, these countries in blue, they terminated their participation. And so we have had to continue our contribution with the results to the European part. We were not excluded from that program, but we switched our interest nowadays to air pollution in Asian countries. Last November 2022, I was invited as an expert to online expert group meeting on review and analysis of air pollution trends in the Asia-Pacific region. So now from European country of interest in Europe, we move our activity to Asian countries and Pacific region countries. And really they need this, because these countries, in some sense, you will see some graphs later, you will see they really need air pollution control and improvement of their situation. Oh, Господи. Next, please. According to 2018 World Air Quality Report, Asia-Pacific region had several most polluted cities in the world. All such cities in the region are beginning to see the effects of air pollution resulting from a combination of unclear energy, industrial pollution, vehicles and transport, burning policies, and a number of other causes. You may look at these references. I especially put them for those who could look to my presentation, which I leave open for everybody. And all in all, like 50 towns in India, Pakistan, Bangladesh terribly need efforts on improving their air pollution situation. And the methodology which we use here, MOSIS, is very simple and very cheap, and it could be really used widely. Now I speak to people in Pakistan, they're eager to do their research because they need to improve their situation. Next, please. I would like also to mention that the second online research symposium on air pollution, which I mentioned, it was held in last November, welcomes scholars, researchers, experts, and those with a shared interest in understanding how the present scientific research on air pollution can provide insight and forward guidance to future thematic areas of air pollution research. That is the main, emphasis from the UNESCO, and it's important to follow their, efforts to improve the situation all over and in Asian area in particular. Next slide, please. In our group, we have not, I gave presentation of atmospheric deposition study in Asia Pacific region, because in addition to Europe, we started our research with the member states of the Joint Institute, like Mongolia, Vietnam, some Asian countries, former Soviet Union republics. And Alexander Uzhinsky is one of the key participants of our team. He gave excellent presentation, remote sensing and machine learning advances of air quality monitoring. I shall show you some pictures a bit later, but you should feel the highest level of research. Remote sensing and machine learning advances in, it's a great possibility for predicting contamination in the future, which is very acute and important. Oh, sorry. Next slide, please. Now I want to show the pictures, which I like very much, because at one glance you can see air pollution all over the world. You see the most dark colors correspond to the highest pollution. China, India, even those islands here, United States, of course, and the other countries less, assessed as less polluted, but still contamination is quite high. Next picture, please. Next slide. Yes, that is death from pollution of air, and certainly it corresponds to the previous picture, China and Russia in particular. Of course, Russia, not the whole territory, because there are many empty places here, but the central Russia, which is quite contaminated. And next, please. I also would like to show you the picture, very original one. Look, it's COVID mortality attributed to air pollution from all anthropogenic sources and from fossil fuel. Look, China, Central, European part, and United States, exactly those parts which were mostly affected by COVID area. So COVID is transferred by atmospheric things. So great evidence for this. Next slide, please. So what is air pollution global effects? Of course, health effects, which sound today already. Increasing greenhouse effect, climate change. There are so many thoughts about global warming or beginning of the ice age. This is just preliminary stage between ice age, if to look deep in the history. Of course, acid rain, which were firstly studied in Western Europe and now is well assessed everywhere practically. So actions to reduce air pollution, assessment of the environmental pollution, what we are trying to do on a large scale, and continuous upgrade policies, standards, and guidelines. That's also important thing, but it's not our prerogative. Next, please. Next, please, slide. That picture we may skip because it's very primitive. It shows the pollution sources. Everybody of you knows of them. The only thing what is mentioned should be mentioned, the long-range transportation of aerosols and gases. It shows that just circulation of all these things. Next slide, please. It's just nice looking picture, nothing more. Few words I would say about history of MOS biomonitoring survey in Europe. Next, please. So three great guys, Eke Röling from Sweden, Eilif Steines from Norway, and Harry Harmans, all of them left their, great participation in the MOS surveys, but they prepared the school of youngsters who continue their matter of their lives. Next, please. So that is to emphasize the Scandinavian countries. What is the moss? Some of you probably don't know exactly what is it. Mosses are very specific plants. They have no roots. God created them so. So if we take into consideration, and mosses having roots, what does it mean? They don't take anything from the ground. It was proved in many experiments. Everything which comes to them for their nutrition and for absorption of the contaminants is trapped by these green parts, which annual segments. So if we take three last segments and analyze them for contamination with heavy metals or trace metals, as we say now, even with radionuclides, we can say that for the last 3 years, that amount of air pollutants were observed in these mosses. Next, please. These next pictures I'll just only to show you briefly. These are different kind of mosses. No time to speak more about them. Next, please. Next slide, please. This how they look. You may go out and finally look on the ground and find some mosses even in your environment. This is just picture to say it's quite easy to collect them. This methodology is rather cheap in comparison with examining air pollution filters. Next, please. So here you see the teacher who collect mosses, because in Dubna, from time to time, teachers are coming, school teachers are coming to our institute, and we give lectures to them. Mostly they need to know what to say to youngsters about, say, hadrons, about Higgs boson or whatever. And usually I'm giving a word to 30 persons coming from all parts of our country, even from abroad. And I tell them about this methodology. And if I speak to 30 persons, 2-3 of them approaching me saying, we would like to do something useful for region where we live. I teach them, I send them a lot of experimental material. They collect mosses like that teacher, Inna Vikhrova, teacher of physics from Tikhvin, is Leningradskoye region, St. Petersburg region. Next, please. So mosses are very abundant in our part of the world. And the importance of our studies demonstrated in that slide. Look, in 1990 situation with lead, you see these red spots. Lead was used as just a part of petrol, addition to the petrol. And now after the lead was forbidden as impurity in the fuel, situation improved. 2005, 15 years, and situation considerably improved. Look, lead here, from that to that, 75%, 72% precisely. So it's very important to get the picture of the pollution and to give recommendations to improve. And the ways of improvement are different for different countries. That was just a brief, no time to speak more about other elements. Next slide, please. That is results from any MOS survey. MOS surveys are organized every 5 years. MOS surveys is announced all over Europe. And here you see the so-called atlases or reports of the MOS surveys. And the last report on 2015, that was coordination by the Joint Institute for Nuclear Research. Next, please. Next slide. That is the cover, which MOSES as biomonitors of air pollution 2015-16 survey on heavy metals, nitrogen and POPs in Europe and beyond. So it's not only heavy metals, but also persistent organic pollutants, which is very important. Sometimes people say, we know everything about contamination with air heavy metals, but POPs are most fashionable part of our research. There is no word radionuclides here because not many country has access to measurement, say gamma spectrometry for measuring radioactivity. But several countries like Greece in particular, I say to you, Elias, Greece, say Macedonia, some other countries in Europe and here in Russia, we measure radionuclides and report our results on our private communication. Next, please. Next slide, please. So all in all, we may say in 2070s, the beginning of the heavy metals was most fashionable part. Then people decide, we collect mosses, why not to determine nitrogen? Nitrogen is very important, you know it better than me, for agriculture. Then the role of persistent organic pollutants starting from 2010. The problem with organic pollutants is simple. The analysis is very expensive. One MOS sample analysis for a good set of organic pollutants, persistent organic pollutants, and their variation cost €200. It's quite expensive analysis. Radionuclides. The role of mosses in determination of radionuclides was known even starting from 1980, but we implement them in our research starting from 2015 in our first survey, which was conducted from the Joint Institute for Nuclear Research. And my great desire to include cosmic dust in our research, because cosmic dust in great amounts come on Earth, it's a well-established fact, but their role in agriculture, in different, say, influence on health effects, not well studied. So cosmic dust probably in the future will play the same role as heavy metals, which are well known in Europe as the most important pollutants. Next, please. So please, that picture shows the number of the countries who collaborate with Joint Institute for Nuclear Research. Not all of them are Joint Institute member states, but some of them, like say, Armenia now is, Turkey, Greece, Macedonia, they're not member state, but we collaborate with them. We analyze their results using neutron activation analysis. And here participating countries who collaborate with us, you see this list. And some in red, they are not member states, but we collaborate with them and publish together results. We don't charge money from them. It's for free for those who would like to work with us. Keep in mind this aspect. Next slide, please. We use neutron activation analysis. Because I don't show it myself, it's animation picture. That is the reactor, and our installation is on the ground floor of the reactor, but so I can show it to you. I switch it. Next, please. Next, please. Joint Institute, Regatta. It's our it's a poetical name of our installation for neutron activation analysis. But one day it came to my mind to decode this word, Russian European gate to Asia or Africa. It depends where I give my talk. Next slide, please. Well, mosses are prepared like pellets. We use just devices to compress mosses. And finally, we use this pellet for analysis. Is it packed in aluminum foil? It is weighted. These aluminum foils are used for long-time irradiation, and plastic for short-lived isotopes, which we determine in our research. All in all, next slide, please. All in all, we determine up to 55 elements. Those 3 elements in yellow, lead in principle we can't determine because lifetime is millisecond, too short lifetime. Then cadmium and copper, we can determine if concentration are large, but if not, it's better to use either atomic absorption spectrometry, which is very easy to use for determination of these elements, or ICP. Now we purchased ICP, and for example, when atomic activation analysis is impossible, if reactor is shut down for some reason, we can use ICP hours. So these elements we report to the atlas, and you see the list is quite sizable, I would say. So all heavy metals are presented here. You see mercury, you see heavy metal like zinc. Antimony is very important. It was not used to report these results in the beginning of the program, but nowadays the list of elements extended, and it well represented to assess contamination in air. Next slide, please. Next slide, please. Due to our institute, we have laboratory information technologies with excellent programmers, which established so-called data management system. On that side it exists. You may even look at it. You will not be able to enter deeper, but you will get impression. That is welcome to data management system. So every country could, nowadays England probably will arrange something of the kind. All countries could report their results. Results are summarized and interpreted using different program software developed by that great team of from Laboratory Information Technologies. The program of the United Nations was well equipped with all software for interpreting data. Next slide, please. And we do hope that it will continue. Prospects for using data from space images to predict the concentration of heavy metals. That's what I mentioned in the beginning. It is also done by our researchers from the Laboratory Information Technologies. Next slide, please. What does it mean to compare space images and predict concentration? We compare images, space images, with MOS data, and finally we can form such pictures which can demonstrate, just roughly speaking, it's a kind of modeling. We can predict what could be done further with the air pollution which we observe at present. That for antimony. You see, quite strong contamination with antimony comes from vehicles. Finally, it was decided. But antimony is not easy to determine. Not many methods can determine, would except, say, ICP methods and nuclear analytical techniques. Next slide, please. That is the picture for MOS Survey 1516, which was conducted from the Joint Institute. Here you can see small spots even in Asia area. That's why for us it's interesting to move to the east. And that part was, even this island was included in that MOS survey. Next picture, please. I'm in a hurry because I'm afraid I won't be able to finish in time. So that picture on a larger scale gives. So you see the dense net, quite dense net for Europe and for Scandinavian countries and for this Iceland. Okay, next please slide. I'm eager to show you the result. So all information, because we have coordinates for every sampling site, it allows us to build maps. One thing, to look at the figures and to compare them with the detection limits or just allowed permission levels. But the other thing, at one glance, to see the whole picture, you see for arsenic, territory is clean. Two pictures here, that is Russian territory. We will contaminate Norway a little bit here, but most contaminants, southern Europe is contaminated, and Caucasus. Arsenic is known contaminant in Georgia because there are great plants where now they are shut down, but still contamination exists because it used for many years, starting from the beginning of the last century. Next picture. Very briefly, we shall show you some pictures. Cadmium. You see also contamination in southern Eastern Europe, in Russia in particular. Next slide. For cadmium. Cadmium is a very toxic element. Toxicity of group toxic elements from chromium. Chromium, valency 6, is very toxic. And for example, here you may see some places near St. Petersburg, Tikhvin area, ferrochromium plant is here. So they see contamination here, Caucasus again, and these countries, Bulgaria, Romania, contaminated enough with chromium. Next, please, very quickly, just to get an impression. For copper, the same story. Here you see Caucasus and some places in Europe. Next, please. Next, please. Iron. Iron, where iron industry is developed, certainly we see high content of iron. Look, what is the difference here? Background area, green area, less than 250 milligram per gram, but in red areas, 4,000. Can you imagine? If concentration decrease the background 5 times, it means ecological stress. So all these red areas are under stress from iron and relevant elements. Iron does not exist. It keeps the whole group of elements. Next, please, slide. So at that picture, you can see comparison where, say, Romania, Macedonia, Albania, I especially marked Russian Federation, say for aluminum, antimony. Antimony highest in Romania. Probably some plants exist there. For arsenic, Russian Federation quite good in comparison with our people on European countries, by the way. Cadmium, the same story. For cadmium, we are in the end of that scale. Next slide, please. The same for other elements. You just get an impression how we could present data. Next slide, please. Here you can compare 2015 and what was done during the 2001, and we prolonged it for 2022 because of the COVID. All in all, here we collected 5,000 samples. In the COVID years, 3,500. So you see the map of sampling. We do hope to get results very soon because data are transferred to UK, and UK will provide data analysis for this MOS survey. Next picture, please. Here, just on a larger scale, you may see the dense network which is used for Norway didn't participate this time because they said we know enough about contamination, it doesn't change. But Sweden presented good set of samples, and that part France and Germany. Next slide, please. Very briefly, just I'll show you some territories. For example, you see Slovakia. Slovakia, we have great scientists there who are very dedicated and they work hard. Those red samples they collected in 2022, in addition to those net which existed previously. Next slide, please. And you may change slides quite fast. You see, Slovakia is quite industrialized country, so many pollution sources here, and they have very good network for moss sampling, practically fixed territories where they collect mosses every moss survey. Next, please. Next, please. That is small country Moldova, and you see it's very green. It's not easy to collect samples, but you need to leave the car somewhere and by foot to go to the mountains to collect mosses. Small country, but it has border with Romania, quite contaminated area, and so even this is an example. Roughly difference. You see the scale here. Distance between sampling sites should not be less than 20 kilometers. What does it mean? Without car, you do nothing. You should drive car and to stop to collect mosses and go further. Inga Zinkovskaya, now she is the head of the department which I led for more than 20 years. She is very interested in air pollution research, and I hope with her help, many of you who is interested to join us, you will deal with Inga later on. Next slide, please. This is just only to show you Italy. Italian guy Stefano Lopi, now he intended to organize association of biomonitoring on a large scale, not only air pollutants, but also you see they collected samples in Siena region. Next, please. Just to show you like an example, this is Moscow region. Moscow region is very contaminated region because of the satellites, industrialized town around it. So Konstantin Vergel, it's my former student, now he is associate of mine. They collected samples in Moscow region. Moscow region, a lot of mosses there because it's quite wet territory. Next slide, please. That is to show you the scale on which we work. So a lot of samples collected, they come to Dubna, we analyze them. That is, say, North Ossetia, Alania, Caucasus. Next, please. Next slide, please. That is the same country. They wanted to put their samples practically in the middle of the squares 20 by 20 kilometers. Next slide, please. That is Chechnya. Oh, okay. Chechnya also collect. Chechnya is interesting because of military activities in Chechnya and further, and we see how this activity affect the territory terribly. What are fireworks are nothing with the sequences of this. The previous one, please. No, just one more. I would like to emphasize maybe somebody from Serbia are here. You see these two guys participated most in, say, 1999. And this guy, this is the son of this gentleman. And in 2020, his son went to moss collecting. That is to emphasize that Serbia is very interested in collaboration with us. Nowadays, they can analyze samples themselves using ICP-MS, but still neutron activation analysis is very reliable and good technique for this research. Next slide, please. Now we switch to some example in Asia to show our experience to work in collaboration with Asian countries, Kazakhstan, Tajikistan, Vietnam, Mongolia. Next, please. So Kazakhstan, also very huge country. What to say about Russia, but Kazakhstan is huge, and we can find students in Astana University which collected samples in those, say, areas marked in red circles. What to do? They did it voluntary for their master and PhD diploma and thesis. Next slide, please. So even in that is also example from Kazakhstan in Almaty, and that is the now these are mountains, and you know Almaty and Semipalatinsk on one side, and on that side there is Chinese polygon for testing nuclear weapon as well. So that territory is very interesting for air pollution from radionuclides side. Next, please. And I'll give you some examples. These are mosses. Mosses, of course, chosen special mosses. That one which I showed you the first, it was Hylocommon splendens with definite segments. But there are plenty of mosses which have no such segments. So we take into the analysis, they say greenish part, greenish brownish part is taken to the analysis. So we just develop technique. We make intercomparison of moss species and insert correct connection due to the type of moss used for determination of trace elements and radionuclides. Next slide, please. It works slower. Next, please. This is the girl in Kazakhstan, some small areas, and you see these dots. It's a local contamination here, but still territory. Still something we can say about distribution mass for tungsten. Tungsten is hard metal. It's even more dangerous, and the concentration in that particular area, which is considered as a contaminated area in Kazakhstan, because Kazakhstan, the whole periodic table, as you know, that's why it is interesting so to the Western countries. Next, please. The same map for another element. It's for iron, also quite high concentration. Look, 5,005, 10 times higher than in background areas. Next, please. We need to find money to implement our research on a larger scale, because to get grants for air pollution using moss is quite difficult. Why? Because mosses are not, accredited methodology. We need to accredit methodology before to get money from the state. For Vietnam, for example, we published an interesting paper with many participants from Vietnam, investigation of airborne trace elements pollution in Hai Phong City, Vietnam, using Barbilla indica mosses, mosses which are growing mostly in the southern countries. Neutron activation analysis was carried out in Dubna. Next, please. Now time is going on. We need to be very quickly. That is the moss which previously was not used. We just tried it and it works very well in Asia. Next, please. Please do it quickly. Now I want to show you. Everybody, of course, know where Vietnam is. Next, please. Press the button. You will see. Press the button. Vietnam is here. Next slide, please. No much time to speak more in detail. So that's logarithmic scale country. We carried out some research in that part, but we do hope to do the whole Vietnam in the future because they are very active in that research. Next slide, please. These are typical areas which are shown in Hanoi. It was territories which were sampled. You see the numbers of samples around these things. Please go further on because time doesn't allow me to speak more in detail about these pictures. I want to show you the final outcome of our research in Vietnam. Yes, please stop here. Even two previous slides show me. Two previous slides. For example, you see Hanoi is that orange, that is logarithmic scale. Can you imagine for Hanoi contamination of arsenic the highest, for cadmium the highest, practically with Poland, with some other Vietnamese town. Again, for lead is toxic elements and concentration is high. It's logarithmic scale, so it shows the quite contaminated area with this element. Next slide, please. That is for uranium and thorium. And again, you see the Silesia and Poland, very low concentration. In Vietnam, this concentration are high. The reason is not quite known. Probably they just, the deposits of these two elements are in the area, but it's not quite clear at the moment. Next slide, please. What I would like to say that our research allows us not only to provide results, say data, concrete data, but only to interpret data in terms of factor analysis. We could group elements and to say what elements are responsible and what is the sources of these elements, which is just to mention. Next, please. And also important to emphasize that many of you, I guess, who are present at this event, they are from universities, from high school, and they might be interested in their career, in the growth. I'm very proud to say that our results, which are obtained by analytical techniques, never mind what analytical techniques, like here, instrumental neutron activation analysis and ICP-MS, that was carried out in South Africa. This girl, my child, from South Africa, her long name, and difficult to pronounce for me, but something Zikhona sound here. I called her Zina. Now in South Africa, they called her Zina. Zina defended her PhD, elemental analysis of mosses and lichens from the Western Cape using these two methodologies. Next slide, please. This girl, Shanika from Albania. Albania is not a member state, but I addressed to our directorate and they allowed this girl, they financed their staying for half a year. And finally, air pollution in Albania, the book, her thesis in her hands. Photo taken in Budva, we had a meeting there. And my last PhD student, the previous one you missed, I guess, please return one slide back. No, next. Please, next slide. One was missing from Macedonia, but never mind. The last defense was BRIO indication atmospheric deposition in the Republic of Belarus. That girl defended her PhD. Defense was carried out in the university named after Kant in Kaliningrad, and her defense was on the 10th of February of 2025. In 10 days, it will be impossible to carry out her defense. Well, sad situation. Sorry. That is not, no. Must be no. Please show the last slide. I like that slide very much because it is not mine slide. I took it from some reports of the youngsters who come to us for practice from South Africa, from Eastern Europe, and we on the Laboratory of Neutron Physics. You know this word, Dream Team. It was called by some of the students, Dream Team. It's worth to work and to teach youngsters to share our knowledge and to prepare them as a scientists. Next slide, please. And the very last slide, to launch a program on air pollution studies in Asia-Pacific region. That is the purpose of my present intentions. And the very last slide just shows the beauty. Next slide, please. Shows the beauty of the joint of the Dubna. We have Volga River. In summertime, you may drive the yacht. In the winter, you can use any kind of sports. We have a lot of swimming pool, many possibilities for hard work and good rest. And that is Joint Institute for Nuclear Research. Thank you for attention. Excuse me for the time I use more than necessary. And I do hope you will ask me questions when time comes. Thank you again.
Thank you, Professor Frontansiva. Thank you for talking us through your detailed research survey on the MOSIS as the biomonitor in air pollution. Thank you so much for the interesting and enlightening speech. And now let's move on to our last part of our agenda, the Q&A session. So from our Q&A box, chat box, we can look that we have several questions here. So for the first question, do these fireworks affect people with Alzheimer's disease?
Oh, hi, this is Peter here. Yes, very interesting question. And Alzheimer's is probably going to be affected because the particles are very, very small. And once you breathe them in, they can get into the brain. So I do think that is true, although we don't know very much about it. So it sounds to me like a really excellent research topic. The next question I see for me is about the heat of the particles and aerial microbes. Again, I just don't know about that. It's a very interesting question. These hot particles probably don't contain microbes, but you can imagine microbes adhering to the fireworks particles that would cool very, very rapidly. So I think there's some very interesting questions there. Green fireworks, yes. I think that's one of the reasons why in some countries we see a decrease in the concentrations and the emissions of heavy metals, although it's not everywhere. And as fireworks become banned, they've often gone to smaller and smaller factories that don't have green techniques. So I think that there are possibilities of green fireworks, but still a long way to go with that. And yes, I think David White, sorry, I can't quite see it. This is about indoor and outdoor air quality. And yes, I absolutely agree. We really, really need to think of that balance, to what extent pollutants are generated indoors compared to outdoors, because it's not the only route to exposure. And during the COVID pandemic, certainly people were exposed to large quantities of indoor air pollution. I think that's all from me, is it?
So thank you everyone again for attending our webinar today. And before I call it an end of our webinar, I'd like to mention a few items before we leave. And thank you everyone, our speakers and our participants for joining us today. And we will have a survey on the presentation after the webinar, and we would appreciate if you would complete that and provide your feedback. And you will also have the access to our recording of our webinar today. And thank you for your participation today. See you. Bye-bye.
Bye-bye. Thank you.
Bye.
Thank you. Thank you.